Bienvenidos, Ushamdi, and welcome to this Hut8 networking Techtorial. In this module, Module 1, we're going to continue our journey in the basic ASA configuration mode here, and we're going to be looking at file system cleanup tasks. In other words, in our previous module, we took a look at how we would break in and either recover the enable password or just simply break into the ASA in order to right erase the configuration and start with a blank slate. And so now that we've done that, we're going to go ahead and get onto the command line. And what we want to do now is we want to clean up the file system. Now, what kind of file system cleanup would we like to do? Keep in mind that the ASA has a file system structure similar to that seen on the ISR, the G1s and the G2 routers, like a 2800 or an 1800 or a 2900 and a 3900. Now, the ASA integrated file system, the IFS, is also known as a Class C file system. So you're probably wondering, what makes it a Class C file system? Well, in order to be a Class C file system, when we delete a file, and we're going to see the deletion of a lot of files, that file system space is reclaimed immediately. With previous versions of the Cisco integrated file system, in other words, Class A and Class B type file systems, you had the opportunity in some instances to recover the file, where you would delete a file, and if you were to do a dir to list the directory out, the current working directory or your present working directory, what you would see is, in terms of space, the file was gone, but the space that the file was occupying was not reclaimed. You had to use this command called squeeze. And this goes back quite a ways. So you shouldn't run into that issue. So again, the ASA is a Class C file system. And when we delete something in a Class C file system, and when we delete something in a Class C file system, that file system space is reclaimed immediately, and that file is gone, and there is no opportunity to undelete and to bring that file back. Now, what we're going to notice is that the file system is very, and I've got that star nix, so very Unix, Linux-like. And we've got some Linux and Unix commands at our disposal. We've got the cd command to change directories. Maybe we want to change into a different working directory. We've got the pwd command, which is print working directory. We've got rmdir to remove directories. We can rename files. Now, dir is sort of equivalent to the Linux ls command. In other words, list for me the files in the current working directory. And then we've got the popular makedir, right? Sometimes maybe we're doing iOS IPS, intrusion prevention system, and we need to make a directory in which those IPS XML files are going to be located. So let's go ahead and jump onto the command line here and take a look at the file system. Now, I have two ASA 5505s here. In fact, these were literally just pulled out of the box. So we're going to have a lot to look at in terms of legacy files and things that have just kind of been on these routers for years and years. So I'm going to say no, right? Because we don't want to pre-configure the firewall right now. We're going to clean the file system up before we do anything. So we're going to go from user exec mode, which is indicated by that greater than sign after the Cisco ASA host name. And I'm going to say en or enable to move into privilege exec. Now remember, we've cleaned off these ASAs. So there's no configuration here at present. In other words, there's no enable password. So all I need to do is hit the enter command at the password prompt, and it puts me into privilege exec. Now, let's take a look at some of these Linux and Unix-like commands. So if I say dir, and this is a very common command, we're going to see that we've got all kinds of files in here. Take a look. We've got the ASA code for 825, and then we have the most recent code for 924 because we're going to be doing some upgrading. And then we've got these FSCK files, right? Now, File names that begin in FSCK, and this is again a huge throwback to the Linux Unix days. FSCK stands for File System Check. And these files would be generated, or these files are generated, and they create a record of when a file system check has to be run. So you're probably wondering, well, what would be the catalyst? What would cause a file system check? Well, if I was to simply pull the power cord out of the ASA, that may result when the ASA reboots and I attach the power, when the ASA is booting back up, there's a possibility that when I pulled the power plug out, there were still blocks of data, or I should say still bits of data in memory that hadn't been written out to the flash, right? And in that instance, we may end up with what they call a corrupted file system. And so typically what would happen, and on Linux and Unix boxes, this is very common thing that occurs sometimes, is the file system would say that it was corrupt and you couldn't mount, or in other words, use that file system. And so you would have to FSCK that file system. In other words, you'd have to run a file system check. Now, a quick note, you never want to run FSCK on a mounted file system, right? In other words, on the Linux and Unix side of the house, if the file system is mounted, you don't do the FSCK, right? You would want to take the system into single user mode, and that's how the ASA does it as well. It's when the system is coming up before everything is fully mounted, so to speak, and usable. In other words, before we're able to read and write to the file system, that's when the FSCK would occur. In fact, if I were to switch over to this other ASA here, and let's scroll back just a little bit in the boot sequence, and I will show you exactly what we're talking about. In fact, actually it's not there. Let's take a look over here. We should see it on one of these guys. And here we go. So on the ASA side of the house, it's called DOS FSCK, because how is the flash file system formatted? Exactly, it's formatted as FAT32. In fact, when you buy the SD flash cards that go inside of the ISR routers or inside of the ASA firewalls, sometimes you will format that, and you can format those as FAT32. And so you can see here that DOS FSCK version 2.1.1 starts and runs a repair pass to check and see, are there any blocks that maybe aren't in the proper location? And then it'll do a verification pass. And again, it's going to mount /dev, and this stands for device, and then HDA. And what does that mean? Well, the HD stands for hard disk or hard drive. The A is the first hard disk or hard drive. And it's sometimes confusing because people see the 1 and they say, oh, well, that means it's the first hard drive. Not necessarily, right? So the A indicates that that is the first drive, right? In our case, it's flash, right? Or disk 0. The 1 is the partition, right? So as you can see here, we have a single partition. And that's what this dev HDA1 is. When you look at the FS tab or the VFS tab on the Linux and Unix side of the house, you will see nomenclature like this, indicating HDA, so the first hard drive that the system has discovered on the SCSI bus, and then the partitions 1, 2, 3, 4. You can see that we've got 174 files, and the DOS FSCK for dev HDA1 returned 0, which means success. So everything ran as it was supposed to, right? And again, if for whatever reason the FSCK has to run and we need to maintain a record of what was done, it would be in these FSCK files. Now you can clearly see here that we've got some date and time issues, and those will be addressed when we get into the basic configuration module. But again, we can clean those files up and we can safely get rid of those files. Now, this file right here is also a file that we can get rid of. Sometimes you'll see this when you've done an upgrade to the iOS. So what I did prior to recording this module was I upgraded this ASA to 924 and then reloaded it. And that's where we get this config save, because we have significant differences between the ASA code versions. And we'll talk more about this in the upgrade, right? Remember I made that comment about 8.3 code where there were significant changes syntactically with the ASA configuration. So 8.3 and later, so 8.4 and 8.5 and so forth and so on up here to 9.2.4, the way the configuration syntax appears is much different than the way that it used to appear, right? But we still get this config startup save file, right, in case we want to go back. In fact, another Linux Unix command that we can use on the integrated file system on the ASA is more. So if I say more, and we'll copy and paste this, let's see what's in that file. We'll take a look. It basically saved the configuration from 8.2.4. You can see here, and we'll talk about the VLAN configuration, but this was the IP configuration that I set when I TFTP'd or did the trivial file transfer protocol in order to get the new ASA image onto this ASA. And so again, it just keeps a copy of the legacy configuration that was there prior to me doing the upgrade. Now, another file that we can safely clean up and get rid of is this upgrade startup error. So anything that starts with upgrade underscore, we can go ahead and get rid of. And the reason that we can get rid of this is these files are generated when you had a startup configuration and that startup configuration has been erased. In other words, that's why we would end up with a log of the error telling us, hey, upgrade startup error, yeah, there's no startup config here, right? So I'm missing my startup config. In fact, let's go ahead and do the more command, right? We want to see what's in here. So we'll say more, and let's take a look. And it gives us a pretty nice replay of what's going on. You can see here in this version access lists used an access group. So we get some information, and then it's telling me the startup configuration file got saved, right? So this is what's going on. And again, we removed the startup config so that it wasn't there when the system booted back up. So all of those files we can safely remove because, again, they're simply taking up space. They're making it much more difficult for us to understand and to kind of see and get a nice clear view of what we have going on here in the current or present working directory, right? And you can see this is the directory of disk 0 colon, right? Now, disk 0 colon is also synonymous with flash colon, which you may be more familiar with if you have experience on routers. So how do we clean these files up? Well, it's simple. We use the delete command. And again, it's just simply delete, or you can do del. If I do a question mark, you can see that I can specify disk 0 and flash 0. But here's the important thing. And in fact, before we run the delete command, let's print the current working directory. So when I type pwd, it prints for me right here the directory that I currently am in. And so if I'm in this directory, I don't have to specify, in other words, the prefix, right, or the absolute path name to where the files are located isn't required because I am at the directory level where these files exist. So I don't have to say delete disk 0 colon, and then let's just delete this startup config, right? So I don't have to say that. It's going to work, right? And the file is now gone. And that certainly is a viable option. We can see that the file is gone, but I'm already in the directory, so I don't need to say, delete disk 0. I can simply give the file name from right here because I am at the same hierarchy in the same directory where the files exist. Now, I'm going to say fsck, and you're probably wondering, how am I going to delete all of these files, right? This is going to take forever. Well, it's not, and we're going to introduce you to a wildcard character, the asterisk, right? The asterisk will match 0 or more of any character that follows the string that I've typed in here. And this is just a literal string. So any file name that begins with a capital F, followed by a capital S, followed by a capital C, followed by a capital K, and then anything after it, those files are going to get deleted, right? In fact, let's do this, and to make sure we show that it's case sensitive. If I was to copy the running config to fsck0009999.rec and hit enter, right? So now I've just created this new file. If we say dir, that's how we're going to be able to see this file. And in fact, where did that go? It's right here. So you can see that the file is right here. So now let's go ahead, let's clean things up here. So delete fsck asterisk. I'm going to hit enter, and it's going to say delete file name fsck asterisk, and we're going to hit enter. We're going to say, yeah, we want to. But now take a look at what it's doing. It's prompting me for every file name that matches based off that literal string of fsck, all capital, and then the asterisk says anything that follows any file name that begins with fsck, I'm going to match that. So we're basically deleting every file that begins with fsck. But do we see that lowercase fsck in here? And let me speed things up a bit here. We don't, right? But now when I type dir, you can see that we get a much cleaner view of what's going on here inside of the disk 0 or the flash directory. So let's take a look at getting rid of the upgrade. So I can simply say upgrade, or not even upgrade, just up. In fact, let me ask you this, a quick quiz. How many characters would I have to type in to delete just those two files without having to type? What's the minimum number of characters? Well, it would be 1 because those are the only files that begin with a lowercase u. So if I said delete u asterisk, I'm actually matching everything that follows a lowercase u in a file name. But as you can see, it's just those two files. So let's go ahead and we'll get rid of the fsck, the lowercase fsck. And it also, again, it's prompting you, right? It's making sure that you want to delete those files, because if you didn't, you could bail out of it. You could do Control-C, right? Or you could just simply say, well, actually, Control-C was what you would want to do. All right, so let's take a look at what we've got left here. Well, this version of AnyConnect 2.5, this is ancient. So we're going to say delete any and the asterisk, right? That's all I need to put in there. I could have just said AN asterisk, and that would have been enough to match that. Now, let's look at this ASDM. Am I ever going to use 6.4 code on the ASA? Probably not. So delete ASDM. Now, what if I put an asterisk there? Is that a smart thing to do? No, because let's take a look at what that's going to match. So 645, absolutely. 781, the ASDM. I don't want to delete the ASDM software. So I say, I hit in right there, because you can do in as well, and it aborts. It stops it right there so that you can go back and take a look and say, yeah, you know what? Didn't mean to do that, and take a look at what just happened. Yeah, it deleted it, right? Even though it said, oh, I'm sorry, it did not delete it. I meant to say it did not delete it because I hit N. And there's that ASDM. But now we take a look here and we can see, okay, yeah, that was a big mistake on my part. I wanted to get the 62 or the 645 file, which we did, right? So now we're kind of down to not much, right? So we've got a directory log. So remember the cd command. I can cd into that directory. So if I say pwd, what do you think the output's going to say? Exactly. It's going to say, I'm going to print the working directory. In other words, what is the current working directory that I am currently, what directory am I currently in? I'm in disk 0 : /log, right? So if I say dir, is it going to show me all of this when I type dir? No. It's only going to show me the contents of the log directory because this is where I'm at. So if you're in another directory, you're not in, and I'm going to refer to the disk 0 and the flash as sort of the root directory. It's the top of the integrated file system hierarchy, right? So if I wanted to see what was in there, now I would have to say dir disk 0. I'm sorry, not dir disk 0 log. I would say dir, I could say dir flash actually. And no files in the directory. And it's actually listing out where I'm at right now. We should be able to see, let me do show flash. All right, so the show command is the alternative. I was under the impression that we could type dir disk 0 and it would not print. You can see what it's doing here, right? It's actually printing the directory that I'm in, even though I'm saying I just want to see disk 0. So now, actually, a fortuitous failure is what I like to call this, right? So we've had this failure here of where we thought the command was going to do something that it didn't, right? And again, this is in Linux, you could definitely get away with that. And let me see, actually, would it work with this? Ah, there we go. All right, so you have to put that first /, right? That sort of indicates the top of the file system hierarchy. And again, I've got my Mac here, so let's take a look. So we're on the Mac OS X. So we're going to transition real quickly to the Unix side of the house. If I cd into /temp, you'll notice I had to put what at the beginning of the file name? That /, right? That indicates that root directory. In fact, if I cd to /, which is the top of the Unix file system hierarchy, and I type ls, you can see all of these commands that we've got in here. Or I shouldn't say commands, most of these are directories. If I say ls-l, which is give me a long listing with lots of detail, you can see that anything that begins with a D is a directory. So lots and lots of directories here, although we do have a file that was created. But again, if I wanted to see something like if I go into temp, cd into temp, and I say ls, it's going to show me what's here at what's in this temporary directory. If I wanted to see what was back up at the root directory, I would say ls / and where there's that reboot helper file we saw that I had created, right? So again, very, very Unix-like in the way that the file system behaves in terms of the commands. And so this is how we would see if we're not, again, pwd, I'm in the log directory. If I wanted to say, well, real quickly, I don't want to change out of the log directory, right? I just want to see what's in flash. And I'll say :/ and take a look at that. Works like a champ, right? Now, a nice segue was that show flash command, right? Now, can I say show disk 0? Absolutely. And we just got done taking a look at some of the output from the Unix side of the house or the Linux side of the house. When we take a look at disk 0 here, what do we see in our file system? So let's transition back here real quick. We've looked at a lot of these different commands. We've cleaned up file names that begin with FSCK. We cleaned up the upgrade startup errors. We got rid of the older images, especially that 6.4 image. No need to keep that 6.4 image around. And there's actually on the other ASA, and again, these just showed up today, took them out of the box, picked them up off eBay. There's actually on this ASA right here, if I was to say EN and get into listing the file system out, take a look at that. This is Flintstones era code right here. And when we get into the upgrade module, which is the next module that's going to follow, we're going to go ahead, we'll punch up and see if we can take a look at the release date on 5.2.3 code. Something tells me that's pretty old code. So we've cleaned up the file system substantially on the first ASA. And one of the questions that a lot of learners will ask is, well, what about the format command? Because I already mentioned the format command, right? I said that if you get one of those SD cards, the flash cards, that you could put it into a card reader, hook it up to a PC, and you can format that for use with your Cisco router or with your ASA, right? If you have an ASA, the 5505s that we're working with don't have a flash slot, an external flash slot, like you would find on the back of a 5510 or on the back of a 5520, 5550, where you could buy an extra external flash card, and then maybe you back your configurations up to that flash card as well as to a TFTP server of some kind, right? So again, the format command is going to wipe out everything on the drive, on the disk 0. And so let's go ahead and do that. I know what you're thinking. You're thinking you're crazy, but this is going to be a great stopping point as well as a great segue into that conversation on upgrading the iOS. Because when we get into the module on upgrading the iOS, I'm going to show you how to do it not only when the ASA is up and operational, and we're going to go in and configure the VLAN 1 SVI, and then we're going to go into Ethernet 00, and we're going to put that into that interface into VLAN 1 with the switch port access command, and then we go ahead and do it over the network like that. I'm going to show you how to do it when maybe the ASA that you've just come into possession of, it was completely wiped clean, and there is nothing on disk 0. And so here's what that would look like. I could say format disk 0 : and hit enter. It's going to tell you the format operation may take a while. It's probably not going to take too long here because we don't have much here, right? So I say continue. It wants me to confirm, and it's going to warn you. You are going to destroy all data on the disk, on the flash, right? On disk 0. And I'll say, you know what? Hey, that's fine. I don't care. So format of disk 0 complete. So when we take a look here, you can see total sectors formatted, total bytes formatted. And remember, if I were to go back to the beginning of the boot sequence, you would see that this ASA here, ASA 02, that we're working with, and these are going to be ASAs we come back to repeatedly here, has a 128 megabyte flash. And so we have just formatted disk 0. And so what do you think we're going to see when I issue the dir command now? Exactly. We see nothing. And if you're wondering why this doesn't say 128.000.000, it's because there's overhead, right? There's that integrated file system, that IFS, right? We've got integrated file system overhead. It's got to keep track of the pointers that are pointing to the different blocks. And when we format, just like when you format a hard drive, you end up losing some of that space. And so as you can see here, we're losing about, what, 1.2 megabytes that's being kept and that's used by the ASA for file system overhead, right? Maintenance tasks that it's going to do, files that we don't see right now that it may be using to keep track of the file system information. So you're probably wondering, well, what's going to happen now when you reload this router? There's no ASA operating system on here. Well, let's take a look, and this should actually be pretty quick. And you can see, I was hoping we didn't get to the memory part, but take a look at what happens, right? It says use question mark for help, but I want to say boot, and bootloader is going to run and take a look. It basically, and we'll scroll back up here in just 1 second because we're going to be back at ROM-on. Take a look at what happened, right? Searching that forward slash, right? Remember that top level directory in the file system hierarchy, which is our flash or disk 0 in this case, and it's looking for any ASA image, but there are none because we completely wiped it out, right? So now let me slide back over here to this ASA, and you can see we're going to go ahead and do the exact same thing. But before we do that, we want to use another command here, show file. If I do show file and I say show file information, right, I can list out a file. So let's go ahead and see what kind of information can I learn about this ASDM file, right? And why did we get that error? Exactly. We've been moving back and forth between the ASAs a little bit. So if you don't remember, let me refresh your memory here. Remember that I moved where? Into the log directory. Again, so this is a fortuitous failure. I had even forgotten that I was sitting in the log directory. So this brings up a good question. If I'm not at the top, or the root is a common term used in Linux and Unix, if I'm not at the root of the file system hierarchy, how do I get there? Well, I could say cd disk 0 : / right? But I don't need to do all of that. Just like on Linux and Unix, if I say cd and hit enter all by itself, it puts me right at the top level of that file system hierarchy, which is exactly where we want to be. So now when I say dir, it's going to list those files out. And now when I pull this back, I'm just hitting the up arrow here for command recall. Now when I run the command, I get the information I'm looking for, and it's just an image. It's the ASDM image, right? We get to see additional information about the file, right? It tells us the size, the content type. We get a comment right here, right? So you can pull additional information about files that are in your file system by using the show file information. Now, another option to this show file command here is show file system, and I'll hit enter. And this is also a very good command to keep handy. Now, you're probably asking yourself, why do I keep saying that disk 0 and flash are the same? Well, don't take my word for it. Take a look right here where you can clearly see that when we say show file system, this is going to show me the file systems I have. Here's my size, 40, and how many are free, right? I've got 41 megabytes of free space. So here's the type. You can see it's the disk. We've got read and write permissions and the prefixes. In other words, what ways can I refer to that file system? Well, here they are. I can say disk 0, or I could simply say flash. And so these are two different ways. Again, these are synonymous terms when we're talking about the ASA. If there was an additional, remember that slot that I talked about for an additional compact flash card, right? I could put that in and it would show up as disk 1. And then if I had another slot, if I put a compact flash card in, it would be disk 2. And then that is where I would be able to move the files to. All right, well, as promised, we're going to go ahead and we're going to format the flash file system, because again, we are really starting from scratch here, right? Sorry about that. I'm going to say format, and I could say flash, right? Because it's synonymous. May take a while. Sure, let's continue, right? If I say dir, we've got nothing, right? Absolutely nothing. And you can see that this version of the ASA OS actually, in terms of cleanup and upkeep and things like that, is using much less space than we saw the other ASA, which had a much older version. It was actually booted to the 7.2 code, I believe. So, but again, if I say reload, we've got an empty flash. We have an empty disk 0. What's going to happen here? It's exactly what you would think is going to happen, is it's going to reload. It's going to come up. We should see some error messages here telling us that, hey, I'm trying to find an image to boot to, and there is none. And so let me hit space there to get that going. So there are the error messages there. Nothing in boot. We end up at the rommon prompt. But hey, and actually the rommon prompt, I believe, on this one, and this is, again, good fortuitous failure here, is it looks like the rommon may be set to continually boot. So what are we going to have to do? Let's try Command Escape. If we can get it at an opportune time. And there we go. And now we're at the rommon prompt. So if I was to say conf reg, again, a little review here, take a look. Yeah, it looks like it was definitely having issues, although that is the default to boot. It was definitely having issues, but now that we know, right from our previous module, we know how to go ahead and deal with things at the rommon prompt. So let's get to the rommon prompt, right? And we're good there. And I'm going to say no here. We're not going to change anything because we are going to TFTP a bootable image up here via the rommon prompt in our next module. All right. Well, this is going to conclude our conversation about file system cleanup. Again, kind of a tour de force in terms of the file system that we're dealing with on the ASA, how we can maneuver around and navigate through that file system, the files that we can go ahead and clean up. And what we just saw was we are definitely going to day 0 here on our configuration. We are starting from dead scratch. So we've got nothing, no configs anywhere, and we have formatted the flash. All right, well, I hope you've enjoyed this module. I hope you have a much better understanding of that integrated file system and how to maneuver yourself around, and we'll make some directories as well as we move forward here. But again, remember, very, very Linux and Unix-like. I appreciate your time. Thanks so much for watching, and I hope to see you in the next module.